recording now. And again, thank you so much for joining and taking the time to be with us today in one more of the series of webinars for the Geo for All network of labs, of open source software labs. And today we have the pleasure to have Ian Hanu, who is the CEO and founder of PlanIt Geo, and Clayton Sterner-Overten, who is the director of software development. So they will split the presentation, and I have asked them to please give us a little bit of information about the background on how they got to where they are today and to the developments they have done. A couple of years ago, Ian gave a presentation, and it has been very well received and viewed in the YouTube channel. So we're looking forward to this new update and new developments. So go ahead, Ian, and you are taking over.
Okay, terrific. You can hear me just fine, Raphael?
Yes, perfect, and he's recording.
Okay, terrific. Yeah, thanks for this opportunity a second time to present to this group. It's been a few years. Our company has grown, and just happy to share part of our story if it's useful to others. What we're going to do is I'm going to give an overview presentation on who we are as a company, and then I'm going to pass it off. I'm going to go over the product a little bit, or products that we have here. And then I'm going to pass it off to Clayton, who's going to go through much more detail on the specifics of the technology stack that we use here at PlanIt Geo. And then at the end, I'm going to have maybe 10 minutes or so, hopefully do a live screen share of a couple of our software applications, so we can specifically link the technologies that we're using to those applications and actually show you how they're being used and implemented. So I'll just cover both of our backgrounds real quickly and then dive into things. I founded the company in 2012. My background is in forestry and GIS and remote sensing. So that's all I've been doing for about 18 years, all private sector. A lot of project management, business development, and pretty much anything having to do with GIS and remote sensing for trees and forestry. And 10 or 12 years ago, I made a commitment to basically focus on urban forestry, which is a really growing industry and very fascinating intersection of environmental sustainability, urban planning, in our case, technology, mapping, and also a community aspect to urban forestry and urban parks that we love here. It's really who we are. So I basically provide a lot of direction and vision for the company in terms of the products that we have for software, as well as our services. And then Clayton's been with us for about 5 years now. He's the director of our software development team, and he has a very wide mixed background, only got into GIS and web-based GIS about 4.5, 5 years ago. So he's been really learning and then applying that, and directs a lot of the architecture and the larger decisions in terms of the different products we have and where that technology is going. So I'll let him maybe later on talk more about that. Again, I'm just going to provide a fairly high-level introduction. So we have about 30 staff. We're a mix of arborists and GIS professionals and urban foresters and web developers. So we have people who really talk trees, and we have people who really talk technology in terms of web and GIS application development. So at a high level, this is how the company is structured. We have about half the company roughly on the software side, as you see on the left. And we have our services group. We actually use our own software. So we have arborists that use the tools in the field, collecting data, doing assessments, those sorts of things. And then we have our GIS, geospatial group, which it also heavily uses open source software as well in a lot of the scripts and the models that we run for various computation and so forth. From a practitioner standpoint, this is our space. We work with clients. We have around 210 software clients worldwide, from England to Australia, and of course the majority in North America now, and a handful in other countries. But these are the conversations that we have constantly, is dealing with data management at an individual tree or other asset level, so park data, all the way up to landscape scale analysis of looking at land cover change in cities and things of that nature. So really, again, those are how the services and software is a blend for our company. But we've developed and designed our tools to work for various planning, analytics, obviously visualization, mapping, data collection, but we also use that information to then do further, say, inspections, budgeting, work orders. We even have a crowdsourcing module. So it's a very comprehensive set, basically, of tools and applications and modules that we have to talk to clients and enable them to do all these different things. Oh, I think I clicked twice. Let me go back. Again, at a high level, the suite of tools is called Tree Plotter, and Clay is going to talk a little bit more about how each of these use the different technologies in our stack. So I think I've covered most of this, and I'll be showing a couple of examples at the end about those specific tools and, again, how they use the technologies that we use. So everything is GIS based and map based. It is also web browser based, so we don't currently have any native applications, iOS or Android applications. So everything's browser based and cloud based. Data is collected in real time. You can be online or offline. Obviously, a lot of mobile emphasis here from the very beginning. And everything is subscription based and also fairly customizable and configurable. So those are some of our tenets there. We started off, let's see, 2013 with really exploring some ESRI technologies and using, ArcGIS Online, and Clayton's going to go into that in more detail. Again, everything these days for our web-based software is all open source. I should say almost all open source technologies. Again, from how we sort of design things, on the left, these are databases or data layers in the applications. And then on the right are tools that we give the users to work with those different databases and those different map layers. So just a real high level kind of introduction. And I'll have a chance to show you a few of these, like filtering in the map, doing spatial interactions, and then having that come back and update your data tables or pie charts and things of that nature. And just the last slide I have for the intro is this is just a quick shot here of data in the interactive map, a legend, being able to click on a feature, a record in the database, have various tools that you can use at that point. Clicking details would open up an editing form. You can then do your data edits and then move on to the next asset, so to speak. So that's where I was going to transition and hand off to Clayton. I'm just going to move over and let him pick up. But that's just a real high-level overview of who we are as a company and some of the software products and the types of users and audiences that we work with. So I'll stop there and shift over to Clayton.
Hi, thanks for having us again on this webinar, Dr. Moreno. Where we began, so as Ian was saying, when I joined the company in 2014, Tree Plotter version 1 was in use, and it was based on Arc Online. I'm sure a lot of you have seen or used Arc Online. It's an Esri tool, and it's very popular. It ran using .NET ASP on a Windows server, which is pretty much the opposite of open source. And it was great. I mean, it still is great. I've seen Arc Online in use on a regular basis, and it's a really good tool. But it had limits in terms of offering a software solution for our clients. There were limits to a number of operations and to the size of the operations. So, for example, you can only do operations on 1,000 features at a time, which is very limiting if you're trying to build a software system. Limits to other sizes of things, in other words, to the amount of data it would process. And it was very slow for some operations. But more importantly, there was no legal way to grow the business and our software without engaging with Esri and basically becoming an Esri reseller. In other words, it required any user to have an Esri user account, or we would have to, again, create an account in their system for every single person that was going to use it independently, and fees are based on that. So there were charges in some by number of features or by the size of data stored. Creating an Arc application infrastructure. So, for example, taking, not using Arc Online, but creating our own Esri solution has an entry cost of tens of thousands of dollars. In other words, to get your first server is expensive, and that's just the beginning. And for a software as a service, in other words, to resell your software with Esri, we weren't in a position to even look into what we would have to do licensing wise to be able to again set that up, and it would be based on things like the number of users and so on. So we were looking at our choices at the time. Again, this is about 2014. Mapbox was really rolling along full steam at the time. You had CartoDB, Oracle has a geospatial solution. Looking at all of them, and then of course there was the open source stack, Postgres and PostGIS, which are still out there. When we looked at the cost, Esri, Oracle, and others, again, would start at tens of thousands, even for the basic server. Cloud-based providers like Mapbox and CartoDB, again, charged by the amount of data or features. Again, these things have changed. I'm not speaking for those companies or for Esri or anything, but our analysis was that, generally speaking, the fees were based on use or users or gigabytes stored and so on, and that would ramp up over time or based on how much how much of that resources you were utilizing. We had to ask ourselves, what can our developers work with most productively? That's an important choice. In other words, if you have a team that is experienced in .NET or a team experienced in Java or anchored in any technology, that's going to influence your decision. And at the time, I had come out of over a year of working with LAMP stacks, the open source Linux, Apache, MySQL, and PHP solutions, and our new developer, Michael Gentry, who is our lead developer and a remarkable developer. His skills were also in that area. So we had those skills around being able to develop in PHP, and though we didn't have Postgres, we had MySQL, and that's very similar. So we had to analyze what skills we have in the team, and we had to ask ourselves, do we have the ability to create and support our own software stack? And anybody looking at going this route is going to have to ask themselves that. I'm not implying and wouldn't, having worked with both .NET and Java technologies and professional environments, that those environments are easy, or that they don't require creativity to put together a solution or anything like that, but rather there are certainly limitations. There are certainly things that are on your path that are set. Whereas, if you're going to go the route of choosing the open source stack, you've got to ask yourself, do you have the ability to do it? And do you have the required skills? In other words, you're not going to get the same kind of support with respect to training manuals, patterns, ways of doing things in terms of architecting systems and so on. A lot of this is do it yourself. And when we looked at this and made the choice to go Postgres, the Postgres route with the PostGIS extension, we were really helped by the amount of video content and online communities that were developing and flourishing at that time. And so the stack that we ended up developing is a cloud-based software as a service, multi-tenant platform. It runs on Amazon generic Linux servers. I have a note there that Linux is the greatest open source success ever. And we developed our stack. It's basically a lab stack, Linux, Apache, PHP, and Postgres. It is cloud-based, and most of the ingredients, like Ian said, are open source. There's a couple of exceptions, and they are Google Maps and a chart library that we paid a few $1,000s for. That's it, really. We have been able to, it was very much a conscious decision to go open source, and again, one of the main reasons for us was cost. We didn't have tens of thousands of dollars to get into any of these other areas, but it was also based on our appreciation for the open source world and the wide variety of tools that are under development and what we like about those communities. FOSS4G is really excellent. As an example, if you look at OSGEO, they're running 30, 40 projects, and our stack is basically built on 4 or 5 of their most popular projects. Our next generation of software has no acronym. It's not out yet. It'll be out towards the end of this year. But it still uses PostgreSQL and with the PostgIS extension to power it. That turned out to be a wonderful decision, and still uses JavaScript. But we're also getting into things like containers and other things that we're not doing with the current stack. But once again, it's mostly open source. So the decision we made years ago, we're very happy with. It's gotten us here, and we continue to go in that direction. Our stack specifically is PostGIS, GDAL, Geoserver, OpenLayers, and we also use QGIS in-house quite a bit. And so, as you can see, again, those are 5 of the more popular projects being run by the OSGEO. We're also looking right now at various other technologies, including GeoPackage, which is very appealing, has some, and I look forward to what we're going to be doing with that. I'd say every one of these libraries requires a commitment. Just like if you were to dive into .NET or Java, you've got to learn the language, you got to immerse yourself in the world, so to speak, if you want to be effective. What's different about going open source is you need to get to know, in a sense, each one of these technologies. You need to get to know Geoserver. We have books on every one of these. Not that everyone reads books again, but you know, we've spent a lot of time learning, whether it be through videos, books, blogs, or communities. Each one of these, you see the versions we started on back in 2014. Those versions have come a long way. There have been bumps along the way, but there have been great improvements along the way. Every one of these libraries continues to evolve actively and independently, and so following that is one of the challenges, but also one of the fun things about working with open source. So definitely it requires a commitment and a different kind of commitment than if you're going with Java or .NET, where you're basically able to stay more so in those worlds. You have to select your technologies and then follow them independently. I put at the bottom here a little note: research, don't roll the dice. These FOSS4G technologies, each one of these projects has its own, again, thriving community. When we went with these technologies, Postgres had been around for, I think, 15 years, and PostGIS had been going for quite a while, having started, I think, in a scientific community. But these were all solid, and they continue to be solid. Occasionally, you'll find, again, open source projects that start up and go away. And I haven't specifically looked into FOSS4G projects that might have died out, but there's definitely choices to be made. And if you're a company and you're going to rely on something for a while and you don't want to have to switch, or you know, that's something that you want to look at. And you also want to research these things and know exactly what they're capable of and what your limitations are. Good, bad, and ugly. Dr. Moreno asked us to go over the good, bad, and ugly, and so I'm grouping a few things into those buckets. I just have a lot of good, not so much in the bad and ugly. Again, we're very happy with their choice. The good, number 1A and 1B for us, again, what had to do with cost. Zero startup costs aside from labor. Now, to a lot of people, again, that's not everybody can do this. Again, you need the developers who have the skills and are willing to put in the time. And I'd emphasize that there is an amount of creativity required that you don't necessarily have to bring to the table for some of these more out-of-the-box environments like Java or .NET. But there are no costs for the software itself. There's no 1B, there's no per user, per gigabyte, or per anything cost, not for bandwidth, not for storage. So again, you pay for, that doesn't mean we don't pay anything for our servers. It means for the software, you're not going to be charged for any of that. And that was the case with alternatives where we weren't developing with strictly open source. It is fun and creative. You know, we create recipes, we build our stack, and we carefully select the ingredients. And again, if we've done a good job, they last for years, as they have. These technologies are powerful and fast. When we first set up our own stack, we blew ourselves away with how fast we could deliver features in a map. You know, over time, things have slowed down, and our next stack again is focused to bring back another rocket boost to this area and to do things a lot cooler and faster in our environment. But again, when we saw the difference of how slow things would load in our own system, or how we didn't, for example, have control when things went faster or slower and so on. It was really a joy to come to this platform. In addition to that, there was no way we could have done anything like host Colorado's tree website, CoTreeView, funded through the U.S. Forest Service and folks here in Colorado. Sorry, probably Colorado Forest Service, but didn't mean to misspeak there. But that site has 500,000 trees in it, 250,000 in Denver alone. You can't do something, or you couldn't do something like that in 2014 at all in ARC Online. Again, at least that was my experience. And we're not even talking about the speed there, but it was just not possible. And then being charged by features, the charges would have been outrageous. And so, but we have that. We have the Colorado website with 500,000 features, and we have the statewide application for Wisconsin with nearly 1 million features and nearly 1 million trees in it. And we're looking to add, for example, perhaps Bogota, Colombia, which is going to come in with 1.5 million trees. And these are small numbers when we don't have to worry about a per gigabyte charge, and we're just talking about rows in a database. So that the power and the speed was really amazing when we first switched over. Getting ahead of the curve is another good. In other words, we can upgrade these technologies when we want. If you get to know each of the libraries and learn how to work with them and upgrade to different versions and maintain them, you don't have to wait for the RPM, the package managed version, to come out, whether that be for Yum or for apt-get on the Debian platform or the Red Hat repositories or anything like that. You choose when you want to upgrade if you can, again, work with the formula, work with the ingredients at that level. You don't have to wait for a proprietary version release. So you don't have to wait for the next version of Esri or Microsoft or Java or whatever it is. You can upgrade these individual libraries as they come out. Now, the bad and the ugly. The bad, again, two sides of a coin. I'm going to say the learning curves and the knowledge acquisition requirements are pretty steep in many cases. You're not going to learn this stuff in a day. You don't have a single place to go to learn some of these technologies. You have to be exploratory. You have to really dig in some cases. You have to join forums and so on. So that's again, that's a wonderful thing, but it has there are two sides to the coin. Another bad is mixing in non-open source technologies. So, for example, when you get to a point where you say, hey, that technology is cool from Google or Mapbox or Esri, and you want to put it in your stack, you might be out of luck. And there may be options, but those options might be very difficult. Right now, for example, we have an issue in Tree Plotter with panning on the map, where the trees kind of seem to ghost or chase you as you move the map around. And part of that is specifically because we are using Google Maps now. I'll come back to that a little later in our application. And because that's a proprietary technology, if you want it to work well, you got to use Google's API and Google's platform. And if you're doing something like we are, which is pulling Google Maps into an OpenLayers web map, that's an example of a consequence where Google's not spending their money to make it work well in OpenLayers, and you're limited with respect to your techniques that you can use without violating terms of their service and so on. And the ugly, keeping up with licensing and such. There's the concept of copyleft in open source, and the idea that if you pull in the wrong library, technically you have to redistribute your software for free and things like that. Again, these things, it's very nuanced, but that's part of the ugly. In other words, you need to know enough about licensing to be able to develop a stack and have it be free of potential legal issues. And that is something that is definitely a challenge, especially for a very small company. You want to look at every library you bring in. You want to put your licenses out there as requested, and you got to keep up with it and make sure something doesn't change. Let's see, and I'm putting it. Yeah, my example at the bottom is the example with respect to mixing non-open source technologies, and we ended up going to. Well, yeah, that's all I'm going to say about that right there. The example, I'm going to give you another example of the complexity involved, the learning curve, and kind of give you an idea of what I'm talking about there with respect to challenges and what's required. These projects are all part of our stack, and in order to build a stack that runs and runs our software as well as it does, you need to, you can't just say, okay, give me all these things and go. Each one of these libraries is downloaded from source, compiled and built using C tools. And again, that's not a skill that all developers are going to bring to the table. And again, that's a benefit of Java or .NET, not having to necessarily get into those things, but it's also an indication of somewhere where you have freedom to, again, we see it really, again, as mixing recipes, and we have fun with it. But it's definitely, every one of these individual libraries could present challenges with building. Some of them might not run some of them definitely don't run the same on different, or build the same on different versions of Linux or Windows, because you can certainly put together the stack on Windows if you wanted to. So again, it's that idea that every area is something that you have to pay attention to and get involved with. Let's see. Oh, that's a duplicate slide there. A couple of real examples, which Ian will demonstrate a couple of them from Tree Plotter later. I identified we built for University of Minnesota and the U.S. Forest Service about 4 years ago something called the Forest Carbon Explorer, or Forest Carbon X. You can look that up if you like. That's also a 100%, that is 100% open source, similar to Tree Plotter, and we built it around the same time. And we use things like the ST area plus queries on the PostGIS database, or we literally query raster files, query TIFFs using PostGIS in order to, or GDAL rather, to get data. And then in Tree Plotter, you know, trees and other assets are stored again in PostGIS. We have a very advanced filtering capabilities, which relies heavily on the PostGIS functions, especially, of course, if it has to do with any kind of spatial query. We have an uploader tool. Again, that Colorado Tree View app, one of the cool things about it is that any city in Colorado can upload their trees. And when they do that, they can use a shapefile, and it can be in any projection. So all across Colorado, you have different small forest services with their data having different values and different, and possibly created with different systems. As long as it's a shapefile, they can bring, or a CSV, they can bring it into the CoTreeView app and upload. And using the Ogre libraries, the shapefiles are converted to a Web Mercator projection, and all the trees are then in there in one place, and you can query all these trees in Colorado from everyone that contributes. Our exporter technology is completely reliant on these technologies, Ogre and PostGIS, for example, to be able to take data in a database or some other form and to convert it, whether it be to GeoJSON or a CSV or a shapefile. So now I'm going to go through each one of these in a little more depth here. The total work to you. Okay. And so PostGIS. PostGIS is a PostgreSQL extension. Again, it's hard to talk about how wonderful PostGIS is without first saying how wonderful PostgreSQL is. I put here, I'm wondering, if Linux is the greatest OS success story ever, the PostgreSQL database, I think, has got to be one of the greatest success stories of this last 10 years. And I think most people were, well, I can't speak for most people, but I know there's a lot of people out there that would agree and say it's a very exciting technology. It's a really cool database, and there's a lot to say about that. But we're here for FOSS4G. PostGIS itself extends that database into a geospatial platform. And you know, it's not just adding the ability to store data in a geometry column. That's one of the things it does. You can store with various types of geometry. You can create a table and have mixed geometries in one column. You can have points, lines, and polygons in all the same column if that's what you want to do, and it will store projection data. But more importantly, it requires GDAL and GDAL and Ogre, and so they're going to be there when you install it, and it leverages those libraries to do things, including There's the ST functions, for example, built into the database where you can actually literally write queries like ST_area to select an area, or reproject, or determine the projection of, all the sorts of things you need to do with spatial data. But also, because again, GDAL and Ogre are required for that installation on the server, so to speak, at the command line and accessible through scripts, you have the ability to manipulate data in all sorts of ways. The exporting to various data formats was an example I gave, and the importing and converting into the database from various formats is another example. And these databases using everything we've done since our first version. And like I said, we're sticking with it. We're going into our new stack. We looked at other databases. We looked at more modern solutions and so on. And Postgres just keeps getting better. PostGIS along with it. Let's see. It hasn't been reliably available for installation through Yum, which is similar again to Debian's apt-get or other package managers on our platform. So we, for years, we've had to, develop and modify our method of compiling it and building it and making sure that that it works across the board. Moving on, GDAL. Again, GDAL and Ogre is really a heavyweight, central, and core library with respect to geospatial functions. And my understanding is that PostGIS is in some sense built off it. I don't know where the lines are drawn and so on, but we use this again in everything. So whether it's you can load rasters into your database using GDAL tools, and then query those rasters to do things like we do in the Forest Carbon Explorer, where you can quickly query areas based on. You can quickly query areas and determine the data values in those areas, for example, for a TIFF, or do the same thing with database-based data. The Ogre, we definitely deal more with vector things. In other words, points, lines, polygons, etc., as opposed to rasters. And so the Ogre side of GDAL Ogre is what we're more familiar with. And again, that's used everywhere in our application. Talk a little bit about Geoserver. So we do have a running Geoserver. In fact, when we looked at choices for our new stack, we looked at two projects which are both FOSS4G technologies, and they were both the best options for open source servers in 2014. I'm not sure that they still are, but I believe that both are still going strong. I know Geoserver is. We looked at MapServer and Geoserver, and we chose Geoserver because it was easier to administrate for non-techies and had visual configuration, whereas at the time anyway, MapServer was based on XML configuration files. And we use it to do things like raster file overlays. So if you look at one of our apps, Natural Capital, which is a Colorado-based app, you can see on the left I have a picture there of Geoserver's administrative interface, which is very friendly, especially compared to many of these tools, which we work with strictly from the command line. And then on the right side, you can see that raster, which you can pull up in one of our apps. And so we use it to deliver rasters and serve data. We use it for other things too. We use it to serve. And early on, we used it as a form of integration. In other words, if somebody wanted their features through a WFS or WMS, this was a means by which we can provide that towards them. Again, it's not easy. Once again, this one's Java-based, and if I hadn't come in, or if one of my associates didn't have some Java background, it again would have been starting at zero. There are XML configuration files that are required for doing things like setting up security things. That's what CORS is. You have to do there's sort of Java. It's Java debugging as you're looking at Java logs when you're debugging it and so on. So it's got aspects to it that are challenging, but it's a wonderful solution. Allows us to serve our own data and to have our own map server. OpenLayers. That's our web map. So once again, we're pretty heavy FOSS4G over here. If you open up our software, look at Tree Plotter, any one of them, the map you're looking at is called OpenLayers. At the time in 2014, again, the choice was Leaflet or OpenLayers. We've now used both. We used Leaflet in our offline collector, and we like them both. They're both great technologies. But we chose OpenLayers due to the rich features it has. Tons of features for doing things. in web maps. And once again, it's a good project. It's rolling along, and it continues to add cool features. QGIS is, again, many of you know what that is. That's, again, a huge project. And like a lot of these projects, it's worldwide. So when you join the developer forums, or if you get on these mailing lists, you're talking to people from all over the world. Those are the people who are contributing. Some of them seem to be centered in Europe. Some of them seem to be centered, I think QGIS might have a pretty big base in Australia. I could be mistaken about that, but you see that these things are all generally created collectively by people around the world. And that's exciting and neat. And QGIS is a very powerful, so to speak, alternative for desktop tools like ArcMap, and it just does a lot. We used it specifically for every day, or every week, I should say. Our GIS folks use it for analysis and for viewing data. They also use Esri tools and Arc's desktop versions. But I actually used it to develop a WFS, which is non-FOSS4G open source, or it's actually might not even technically be open source. That's an OSGeo, or sorry, Open Geospatial Consortium technology, WFS. And I actually downloaded and built QGIS from source using Qt in order to analyze our WFS server that we set up. You know, that for those of you who are able to deconstruct what I just said, I think you'll realize that you're not going to be able to do that with a non-open source technology. You're not going to be able to build it and look at the actual logs to see what's coming in and happening. And that's something, again, you can only do with open source and challenging and fun. I think I got 5 more minutes here. Yeah. Okay. Going to throw out a little bit more about non-OSGE open source technologies we're working with. In other words, we're not limited. FOSS4G is incredible. OSGeo, again, the number of projects that they're shepherding and their success and so on, and their growing popularity in this time, which is no surprise, is all very cool. But there's a wider world out there, of course, and some of the things we've looked at are Mapbox vector tiles. We haven't ended up incorporating that into our stack, but if you look at the bottom 2 pictures there, those are examples of using Mapbox's open source technology to show the 253s in Colorado, in the Denver area, and to be able to present them in a pannable, rotatable map. And dang, it really looks cool. And we're going to be incorporating that technology more and more over time that allows us to process and display big data sets in a visually interesting way. The one on the left shows the GIF there, animated GIF shows that you can store tree height and actually show 3D data. And so we'll be leveraging that as well. Mapbox has other things that they did open source, such as Raster.io, which we find is a good alternative to some of the GDAL tools for analyzing rasters. Fiona is, I just mentioned, some of these things are ported into other languages and get another name, but we use Fiona, for example, to analyze raster data as well, and that is, or rather, analyze data as well, and that's a Python port of the Ogre library. And then over there on the right is a picture of an app. We actually had an intern, Jake, our intern, largely built that using an open source augmented reality library. We're very excited about that. It's a cool picture, as you can see, where you can hold up your phone and you can see the names of the trees. It's not using AI to identify species or anything. Those are trees in our database with a location. So by holding it up, you get that augmented reality layover, and that's an open library written in JavaScript. Some conclusions, and again, a couple of points that we're bringing to the table based on what we're looking for out of this conference. What are our highest priorities to enhance the use of FOSS4G technologies? Learn more and leverage more. We're learning about GeoPackage right now. It's got a lot of neat things about it, but also keeping up with the versions. In other words, each one of these libraries gets better every time. So our highest priorities are basically to leverage what's there and to learn more about the libraries we're not using. Pros of wisdom. I think I've emphasized this sufficiently. It's do it yourself. You're not going to, there are people who have great introductions, great tutorials. I know Boundless and other organizations had at that time and continue to have wonderful ways to bring you into it. But in the end, if you're going to build a stack or even build an application, you know, it's do it yourself. And so read some books, or there's me being a little bit of a smarty there, or whatever people do now. You know, I do a lot more videos now than books, of course, but those O'Reilly books on dedicated to these individual topics, or the free books that you can find, you really, I think it's the book level tech. I emphasize the deep dive, and books are where you're going to get that, whether it be with Geoserver, OpenLayers, or whatever. Be creative. Many things are possible, and again, you're going to find some of those out-of-the-box solutions. You're kind of set out on a course. There's so many things that we've done, and we've done by saying, what technologies do we have, and how can we apply them to this problem? And so that creativity, again, is one of the things that keeps us going. We really enjoy doing this. You got to commit. You got to engage in every technology and be a constant learner. I think, again, that's tied together, and something I've said many times. And once again, keep up with the versions. Things do change, and not so much, well, for a variety of reasons. You want to continually upgrade and have access to the latest and greatest. I believe that is the end of my slides. Thanks very much.
Okay, and I have to remind you, Clayton didn't know anything about any of this stuff 4.5, 5 years ago, which is remarkable. So it's just, I learned plenty myself. These are a few resources, which I'm going to open up at least one or two of these applications. We've got maybe 5 minutes, and I want to leave time for questions, which would venture will mostly be for Clayton. So let me go ahead and we're happy to send you the URL to just a couple of these tools. Obviously, we have a lot more there. I'll just leave this up for 1 second with our contact information. It's just first and last name at planitgeo.com, and you can find that on our website as well. So with that, I'm going to escape, and I'm going to pull up. I've got, let's see, I've got two of these tools up right now. Let me click a couple buttons here. Just give me a second. This is a little splash page that some of our clients have. So just sort of some content, and then as soon as you click Explore, it comes into the interactive map. This is a fascinating project from a ecological standpoint, a GIS standpoint, and then we also, as always, put this into an interactive tool. You could probably have an hour on just this application itself. So I'm just going to very quickly, I guess, relate it to a couple of the technologies specifically that Clayton talked about. So what this is a series of raster data sets across an enormous area, the upper watershed, the Denver metro area, and into the plains. It's a natural capital study, basically evaluating nature. And so we worked with the EPA, the US EPA, US Forest Service, Colorado State Forest Service, and lots of others on this project. It has a whole report, but these are some of the data layers, and basically you can move the map around and then check out the ecological value, ESV values here. So you'll see as I move the map around, it looks at that pixel, and it's looking at a series of information that is introduced in the tool, but that pixel is essentially a cumulative value. So if there's wetlands, if there's access to healthy waterways, access to nature, things like that. We had a couple of really good partners in this project. I don't have time to get into all of it. So again, this is open. Anybody can come log in and play with this. Basically, we're serving up the raster data on Geoserver, of course. Is there anything else really specifically? Yeah, background map is OpenLayers. You can change the opacity, of course, things like that, change some of the background maps. Yeah, so you can choose different project areas. There's also a prioritization GIS analysis, and this one's kind of unique. You can overlay, if you look at the legend, you can overlay a couple of the data layers. You can see the colors change here as I do that. So definitely not enough time to get into it in detail, but this is the prioritization. As you scroll down, you can look at fire, water quality, flooding, recreation, all sorts of different values. So Yeah, Clayton was just reminding me, so there's one thing specifically that I wanted to show with one of our, this is a bit more of a standard application. So this has our tree plotter and our canopy planner software. What we're looking at, I'm going to show a couple of different things. So what's on screen first, we do a LiDAR analysis, a bunch of GIS processing, and if I hover here, we're looking at U.S. census block boundaries. So we can look at the existing tree canopy cover in the urban area, and then we can also look at how much potential there is for expanding tree canopy. And if you look at the legend, I'm going to update here just a couple. You'll see there's some tools here. If I wanted to say, show me all the areas by census block that have the lowest tree cover and that have the most planting potential, I can do that. And yeah, that's the same thing you would do in any other GIS package with a couple of queries, but obviously making that more user-friendly. So I just happen to hover over an area that has 30% tree cover and exactly 30% possible planting area. So that's sort of open space. But we can make this as restrictive as we want. Really look for the areas that don't have a lot of tree cover but have a lot of potential. So that is part of the tool. Let me see. I think one of the things I was going to show, give me just a second here. So there's a series of stats and reports, and I just think a simple example. So I'm going to look at they also do their tree planting and tree tracking in the tool, which is very, very common for our clients. So what I'm going to show is basically the interaction between the map, the legend, and stats, reports, dashboards. So I'm going to click here on, let's see, the name of this is the Springfield Neighborhood Street Tree Planting. Before I click the button, you'll notice if you look at the left, we have this chart, and it has the most species in that across the whole city for what they're tracking are date palms and then live oaks. If I click load trees, you'll notice that chart instantly changes. So now we have, it was date palms, now it's live oaks, that for this specific project, let me go ahead, I'm going to change the base map. There you go, you can see the trees a little bit better. You'll see on the right, there's sort of this interaction between legend, map, filtering in the tool, and then these charts. And then what Clayton was mentioning specifically, if I go to the filter, and this will be the last part of the demonstration, you can filter by attributes, of course. You can also filter in the map. And so what I'm going to do is choose map, and you'll see again the legend as well as the charts get updated. So it's probably, we've had this for many years. It's probably one of my favorite features in the software. Just double click, close. You'll see we went from a little over 100 now down to 52, and you can see the chart here on the left get updated. And it's fun. It's very interactive. I just grab that corner with one of the tools that's built into the, and instantly those numbers hit the database, come right back. So hold on, they won't be able to hear you. You gotta just hold on.
I think if you listen hard enough, you could hear those ST functions running in the background, is all I was going to interject with. So that is, you know, again, data stored Geoserver. This is all powered by FOSS4G.
Dr. Moreno, certainly want to leave time for questions. So I think that was what we had for the presentation. I'll leave the screen sharing up for right now. I'll put our contact information back if that's useful, but happy to answer any questions we have. And again, if they're for Clayton, I'll just have to shift the laptop for the microphone.
Yep. Thank you, Ian. Thank you, Clayton. Fantastic presentation, really informative, and I would say inspirational of the things that can be accomplished with FOSS4G tools. Very, very impressive. So everyone, if you have a question, you can roll your mouse to the bottom of the interface, and on the lower left you will see the mic. You can turn it on and you can talk and ask a question, or you can use the chat bubble in the same menu. So if you can please go ahead. And I'm gonna ask a favor, Ian. Probably we can stop sharing the screen for a second so I can see the interface, the participants.
Okay, stop share, got it.
There you are, so I can see. All right, so again, if you want to use the microphone, roll the mouse to the lower left, and click your microphone and you can ask a question. All right, well, people jump in. Let me ask you guys a question. It's very interesting to see, and it's very informative, as I said, that you are having a successful booming business based on open source software, and that's something that sometimes people that are looking into using open source software still don't understand what are the potential business or economic implications for it. And I think you guys touched on it very nicely in terms of how are you bringing this to within your business. So in the first part, Ian, you talk a little bit about the company and the services and clients. And can you tell us more a little bit about that part of the presentation in terms of who are your clients and what kind of needs they come to you usually? And that would be interesting to hear.
Yeah, certainly. So we have a very diverse client base. I think it's one of the blessings and a curse, right? We really use the tools for a wide variety of audiences. So we probably started off 7 years ago with certainly more clients in the local government and state government or provincial government space. So we probably still today are roughly 50% government clients. So that's cities and counties primarily, but we have about 10 state agencies as well. That Clayton actually talked about this briefly. There's like I said about 10 of them. But what they do is they have an aggregated statewide tree inventory system, and it allows users to only see and edit their data for a specific city. They use it in a number of different ways. Some of it are more for enabling smaller communities that can't afford to purchase their own software. They basically enabling them to have a volume price, let's just say, on that. So those are some clients, state agencies, then obviously a lot of city and counties. I would say our next biggest sector is private consultants. Probably 30 or 35% of our clients are consultants who use the tool. They do tree surveys, inventories, recommendations and maintenance or management plans for commercial properties, for the cities in their area, things like that. We have about 30 nonprofit community foundation clients as well. Most of those are in the U.S., maybe all of them. And they're looking at tree planting, stewardship, education, engagement, awareness about the benefits that urban trees provide. We have maybe 10 or so campuses. Princeton University is one of our tree plotter software clients. So they use the tool, of course, to manage the health, safety of the trees on their campus. What else? A handful of golf courses, of course, homeowners associations. And then the last year, we've had really good success in Australia and England is where we started off. So that's been, again, about 2/3 private companies and about 1/3 governments. And then internally, we use the software ourselves as consultants for our own data collection. We write a lot of reports. We do a lot of studies, ecological studies. We write management plans. So we need to use those charts and graphs and all those good things to go into some of our own consulting work. So it's a very well-rounded group, and it's fun because we have people that they really do very different things. They speak different languages, but we all work very closely together as arborists and as web developers. Were you looking for anything else on that?
No, excellent. That's a very good picture of the diversity of clients that you have and what kind of needs they come to you. So again, everyone, if you have a question at this point, please free to jump in. Again, move the mouse on the interface to the bottom, the menu pops up, and on the lower left you have the mic, and you can unmute it and ask a question, or use the bubble in the same menu and type the question if you prefer.
I'll ask a question. I'm Rebecca Powell at the University of Denver. Thank you for a great presentation and doing the really cool work. And the question I'm going to try and formulate is, how do you plan for the learning time, if you will, for keeping up with new, well, for the amount of investment, as you've said, that it requires to develop in open source? How do you build that into your project management plans, if you will?
Sure. Well, you know, one thing I'm inclined to do is, first of all, emphasize that, again, having worked on professional projects with teams of Java developers and .NET developers, and having used those technologies myself, I have great respect for them, including Esri technologies. You know, I have ArcPro on my system, and our GIS people use Esri every day. So it's and I mention that to say that my background in these other areas allows me to say confidently that if you want to succeed in any one of those technology stacks, it requires you know, your best results are going to come from deeply exploring and learning the technologies. You don't have to go as deep in those other ones to get results necessarily, but it really is about the craft of software development that one engages and commits to technologies and learns. So so my answer is that that no matter what technology set you're working in, if you're going to be a successful developer, you know, it's a given that you're spending a lot of time in these technologies. The challenge in the open source landscape is selecting good resources, or sometimes finding good resources, and sometimes there aren't any beyond the source code, and that's the truth. And so in terms of planning for it, boy, maybe I should think about that and start planning more. But my experience is that it's very similar with working with any technology. You just know it's a given that there's going to be time to ramp up, and whenever we incorporate a new library, we know that's going to be the case. We recently started using a wonderful proprietary technology called FME, and the first many weeks were just pure learning curves. So I would just say it's part of being a developer, with some additional challenges.
Yeah, I don't have a lot to add other than I feel for folks who I've seen in the community. I've been doing GIS in the Front Range of Colorado for 20 years, and there's a lot of people I won't name that just really love open source technologies. They're also at, let's say, a local government. They don't, I mean, we didn't have a choice, right? We just, plus we've also had 6 years to do this. This didn't happen in 6 months. But I feel for them where they really want to venture into these areas. And we've had conversations with local governments saying, you know, maybe we could reduce our fees and go into this direction. But you got to just jump in and be very, very committed at that point.
Yeah, we have seen some of them try and just not be able to break out of their current commitment and their weekly routines. So I think I understand if that might be a good analogy that Ian brought up for where you're coming from with that you definitely have to carve out time, especially if you're immersed in another technology. Does that help, Rebecca? Is that a good answer?
Yes, no, that was a great answer. Thank you.
You bet.
Awesome. Thank you, Rebecca, for that. Any other questions? Sean, I see you have your mic unmuted.
Yes. Hi, this is Sean Gordon at Portland State University. I have a sort of related question. So, as someone who hasn't used these open source tools before, would you have any recommendations about how to get started? Do you rent space on Amazon server? Do you try to set up your own system?
Yeah, absolutely.
You can answer that in 30 seconds or less, right, Clayton?
You bet. You bet. Amazon is great. You can get a free account and use your free 750 hours on a microserver. You can do a lot on a microserver. You can install PostgIS, basically all elements of our stack. Again, I'm not going to say there's not challenges there, but that's the way to do it. And you don't have to use Amazon. You can use, can't remember DigitalOcean droplets or any other thing out there. You can do it on your own machine. You can go the Windows route. And again, in 2014, Boundless was an incredible resource for this. They had packages that would install all this for you and on Windows. And so you might check them out as well.
Great.
Did you say Portland State University?
Yes, that's right.
Okay, yeah, we've worked with Vivek Shandis over there. Do you know Vivek?
Yes, I certainly do.
Yeah, we have a great, we worked together on a project a few years ago, and yeah. Well, I know we're at the top of the hour. Happy to answer any other questions. Again, you have our contact information. We're easy to reach, and yeah, thanks for again for the opportunity and for spending an hour of the day with us.
Yes.
Thank you very much.
Yes, thank you. Thank you everyone for joining us. Again, the video will be posted. I got several requests through the week for the video because they couldn't attend in, live. I definitely want to thank you, Ian and Clayton, again for sharing your expertise and experiences with the community. Very much appreciated. As I said, it's very inspirational, and also it's very good to hear for people that are not in academia or in research, but kind of in the real world, being successful using open source software. And thank you again for taking the time to share with us your experiences and work.
Absolutely, yeah, it was a pleasure.
Thank you, thank you.
Have a good weekend.
Okay, you too. Thank you very much.
All right.